Welcome to ClickMyProject.com. The title of the project is a hybrid convolutional LSTM-based anomaly detection approach for combating energy theft. And the abstract of the project is electricity theft behavior has serious influence on the normal operation of power grid and the economic benefits of power enterprises. In a convolutional power grid, energy theft is difficult to detect due to limited communication and data transition. The smart meter, along with big data mining technology, leads to significant technological innovation in the field of energy theft detection. The smart grid infrastructure generates a massive amount of data, including the power consumptions of individual users. Utilizing this data, machine learning and deep learning can be accurately identify electricity theft uses. A deep learning model for automatic electric theft detection is presented. This process considered experimentation to find best configuration of the sequential model for classifying and identifying electricity theft. This process proposes the different deep learning algorithms are considered to detect the anomaly from energy theft data. Here we propose the artificial neural network algorithm to analyze the energy theft data and generate the result in the form of matrices like accuracy, precision, recall, F1 score, specificity, and Mathew correlation coefficient. And the flow diagram of the project is, first we need to select the anomaly energy theft data set as an input, then it will apply into data pre-processing. In data pre-processing, we are going to checking the missing values, and also we need to remove the unwanted columns from our data set. After pre-processing, it will apply into model selection. In model selection, we are going to select the independent variable and dependent variable. After selecting the independent and dependent variable, we are going to split our dataset into training dataset and testing dataset. In training dataset contains 80% of data and testing data contains 20% of data. Then after splitting, we directly apply into classification method. In classification, we are using three different types of algorithms. One is convolutional neural network, long short-term memory, and multi-layer perceptron, and final proposed algorithms, artificial neural network algorithm. The three algorithms are applied to train the anomaly energy theft data set and find the result in terms of accuracy, precision, recall, F1 measure, specificity, and Mathew correlation coefficient. The program was successfully executed in Google Colab. This is the first module, data selection and loading module. In that, I have to visualize the sample data from our input data. So then it will apply into data pre-processing. In data pre-processing, I am going to check the missing values and null values contains in our data set. So the result of missing value is 1034 columns are containing missing values. So we need to replace the missing values into the unique value of 0. So after data cleaning, it will show the result is false. So there is no missing data contains from every column. So after that, I have to again visualize the sample data set after pre-processing. So this is the sample data set of after pre-processing. So then I have to check the information about the data set. While checking the information, it will show that data type contains from every column. So the 1034 columns contain float value and remaining one column contains integer value. So then I have to describe about the data set. In description, I have to check the count value, mean value, standard value, minimum to maximum values for every columns in our data set. So these are all the described data values. So after that, I have to visualize the number of theft and normal data via count value. Our third module is model selection. In model selection, I have to choose the independent variable and dependent variable. After selecting the independent variable and dependent variable, I am going to split the dataset into training dataset and testing dataset. So these are all the independent variable training dataset and independent variable test dataset, and this is dependent variable train dataset and dependent variable test dataset. So this is the reshaped independent variable training and testing dataset. Then it will apply into classification. In classification, we are going to apply the algorithm. So this is our first algorithm, convolutional neural network long short-term memory. So this is the hybridization of CNN and LSTM algorithm. So it will and take the overall parameter is 1,15,905. So all the parameters are in the trainable form. So our algorithm will going to train our data set for 3 different training epochs, and it will generate the result in the form of matrices like accuracy and validation accuracy. So these are all the results contains from the every epoch. So I have also visualized the number of accuracy and loss and validation accuracy and validation loss, and this is the classification for long short convolutional neural network, long short term memory neural network algorithm. So it will shows the precision recall F1 score value for attack and normal data. So the precision means number of correct prediction, recall means number of correct instance of prediction, and F1 score means to measure the test accuracy. So this is the confusion matrix diagram. The confusion matrix diagram which will explain the number of correct prediction and misclassification by CNN hybridization of CNN LSTM algorithm. So the specificity of CNN LSTM algorithm is 1.0. So this is the Mathew's correlation coefficient score is 0.03. So this is the classification confusion matrix diagram, and the ROC curve, ROC accuracy of CNN LSTM is 68%, and this is the ROC curve for CNN LSTM algorithm. So our second algorithm is multi-layer perceptron. This is one of the neural network algorithm. The MLP algorithm result is 90%. So these are all the classification report for multi-layer perceptron algorithm, and this is the confusion matrix for MLP algorithm. The MLP algorithm specificity is 0.9. So this is the Mathew correlation score for MLP algorithm is 0.25. So this is the confusion matrix diagram for multi-layer perceptron, and the ROC accuracy of MLP is 72%, and this is the ROC curve for multi-layer perceptron algorithm. So the final algorithm is artificial neural network algorithm. So the ANN algorithm which shows the accuracy result is 91%. So these are all the classification report of artificial neural network algorithm, and this is the confusion matrix for ANN algorithm, and the ANN specificity is 0.9, and this is the confusion matrix diagram. So the ANN ROC accuracy is 75%, and this is the ROC curve for artificial neural network algorithm.